All right. Let's go ahead and get started. Call this meeting to order for the San Luis Obispo County Flood Control and Water Conservation District Water Resources Advisory Committee, WRAC, for today, Wednesday, December 4th, 2019. We're going to start with determination of a quorum. So if you're here today in a voting capacity, please raise your hand. 60? No, 18?
I thought 18.
Okay, I'll trust yours. 18.
Yeah.
Thank you. We have a quorum. All right, and let's do introductions. I'm Andy Pease, City Council, San Luis Obispo.
Michael Foreman, Deputy Director for Water for the City of San Luis Obispo.
Marcus Henderson, Water Distribution Supervisor for the City of San Luis Obispo.
Brian Chen, Water Resources Technician, City of San Luis Obispo.
Michael McGraw, Water Resources, San Luis.
Angela McKee, City of San Luis Obispo, Water Resources Technician. Ron Georgia, Oregon City Council.
Tom Gray, District 2 Representative.
George Kendall, Agate Large.
Tim Walters, Development at Large.
Lon Vanhoff, County Public Works.
Ron Lenz, Social CSD.
Greg Graywall, District 5 Representative.
Jeff Cannon, Water Distribution Operator, City of San Luis.
John Murphy, Water Distribution Operator.
Britton Burchett, San Luis Obispo County Farm Bureau, filling in for Steve Carter and James Raines today.
Thank you. We don't Griffin County Underdepartment.
Hey, Nesbitt, Director UPC.
Jeff English, Templeton Community Services District 4.
Marlis McPherson, Morro Bay City Council member.
Greg Armstrong, Napomo CSD.
Ed E.B., Napomo CSD.
Samantha Carter, City Council. Cynthia Russell, Oceana CSD.
David Chipping, Environment at Large.
Linda Chipping, Coastal San Luis RCD. Linda Seifert, representing District 3.
Christine Mulholland, Environmental at Large.
Eric Greening, Environmental at Large.
Lucia Mercado, County Social Board.
Brendan Clark, County Slow Public Works.
Ray Dienzo, Public Works.
All right, awesome. Thank you so much, everyone, for being here today. All right, the first item, business item on our agenda is approval of the October 2nd, 2019 meeting minutes. The November meeting was canceled. So any changes or corrections? Christine.
I have a couple of things to suggest on the minutes. In number 6, the second paragraph, it is compromised that application review will be added. Is that? I didn't quite understand. Is that saying that it was agreed in this discussion?
I think we came up with a compromise and
is that what that is indicating?
And verbalized
compromise? It. Okay, it didn't read clearly to me. Okay.
Do you have a preferable wording?
Yeah.
I would just say it was agreed. Or
as a compromise, it was agreed. How's that?
Well, usually when we have a discussion, we come to an agreement. Or
yeah, sure. We could just say it was agreed.
Consensus or by consensus. It is, I don't care.
Yeah. Okay. So instead of compromise, we'll just say it is agreed that. Is that okay with everyone? Okay.
I'm just cleaning up on number 9. C, Tribune, article trib should be capitalized. And on D, or the next one, D, chipping suggests with an S is the way that we normally write the minutes. So just those little cleanups.
Okay. Thank you.
Move.
Linda.
I think I have a correction, and it's for ongoing updates, and it would be the last sentence in 3B, which happens to be at the top of page 3, and it says, Member M. Broadhurst mentions SLO Valley groundwater basins, Chapter 1 and 2, are now posted for public review. not Michael Rogers that mentioned that.
It's probably about right. Do we know?
Mr. Rogers wasn't here.
Yeah, it was like, who's Mr.
And
Rogers?
Mr. Rogers lives up San Rosa Creek Road. It's Stanford.
All right. So that will be M. Foreman.
Move to approve.
So we have a motion by Tim Walters and a second by Christine Mulholland to approve the minutes as amended. Any other comments or questions? All right. This is a roll call vote.
Yes. And Dennis Laux. Tom Gray.
Aye.
Linda Seifert.
Yes.
Jim Gehring. Okay. Greg Graywall.
Yes.
George Kendall.
Yes.
Tim Walters.
Yes.
Christine Mulholland.
Yes.
Eric Greening.
Yes.
David Chipping.
Yes.
Linda Chipping.
Yes.
Michael Broadhurst. Is Tom Mora here? That's okay. Okay. John Reed. Lee Nesbitt.
Abstain.
Lan George.
Abstain.
Desi Lance.
Yes.
Marlise McPherson.
Abstain.
Marcia Guthrie.
Yes.
Andy Peace.
Yes.
Craig Armstrong.
Abstain.
Cynthia Raplogle.
Yes.
And I think that's it that's present. Anyone that's present that's voting that I didn't call on?
Templeton, Jeff English, yes.
Okay, Jeff English. Anyone else? Yeah.
Farm Bureau.
Okay, thank you. Motion carries.
Thanks. All right. Now we have our ongoing updates. I'm just going to say each of them and then flag me if you want to comment. Rain and Reservoir update.
Happy it's obsolete.
I know, right? It's already out of date. Love that. Groundwater basin management. Michael?
Update just for the San Luis Valley Groundwater Basin. We have a GSC meeting coming up a week from today at Ludwig Community Center. I believe it's at
3:30.
3:30,
I think.
and it's open to the public for anyone who wants to attend to learn more about our sustainable groundwater management plan.
Great, thank you. Anyone else on groundwater basin?
Just a question, can we still anticipate December 17th as the board date for the Paso Basin Groundwater Sustainability Plan?
I think so. Yes.
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 Thank you. Now, the last meeting of the year, so that's good.
IRWM. Oh, sorry, Greg. Did you have a?
Yeah, on the groundwater thing, so at the last GSA meeting, all the members of the GSA board, 4 different members, voted to approve what Montgomery and Associates, the contractor, did on the 12 chapters. So they had to send it back to each of those individual bodies, and then each one will have a document that goes with the big document. The DWR was there. Then they'll accept it. Then they'll have up to 20 days to look at it. They didn't feel it would take that long, and then there'll be a 60-day public comment period. And then it's good to go.
That's a real deal.
And the only other thing which you have in here is the major projects, or the main projects so far, are reduced pumping and stormwater projects. And we just missed an opportunity. They had $48 million to get money from the DWR for stormwater projects, and in February, March, there's another $90 million available. So hopefully, we're trying to get some of that for the project.
Great, thank you. Yeah, exciting to have that come together. Okay, IRWM. That's in here. Okay. Stormwater resource plan. Questions or comments? Any other, let's see, various county water programs, policies, ordinances? Yes, Eric.
Yeah, I have a question. I noticed a few weeks ago the Morro Bay City Council agenda had an item where the city would be contributing funding for a study related to the Delta bypass project. I guess state water contractors may be being approached for this, and some may or may not be contributing. Is the county likely to be approached, or is this entirely happening on the level of state water purveyors, or what?
Anybody know anything about that? Oh, yeah, thank you.
So the State Water Subcontractors Advisory Committee met last week and wanted to recommend to the Board of Supervisors to move forward with that. So the county's going to be holding a study session with the Board of Supervisors to educate them on the issue before it would come to supervisors for a vote.
Okay, good. So that'll happen early in the year?
Probably, yeah.
Yeah.
So the votes by Morro Bay City Council and the Oceano CSD and other state water subcontractors were advisory only. It's the Board of Supervisors who ultimately determines whether the preliminary efforts will be pursued to the tune of over $1 million committed from the state water subcontractors in SLO County.
Wow. Just the SLO County ones, not the SLO in Santa Barbara, but just the SLO County contractors. Yeah, wow. Obviously, the Delta tunnel, it's a little bit less being one tunnel than two, but it raises a lot of issues. And a lot of the question of whether this study is worth contributing to is who will be doing it and what will be being looked at. So is that going to be included in the study session?
Well, the information that I saw from the county, which I guess came from DWP, didn't have any information on the details of what was going to be pursued in the preliminary efforts that were that specific. But there's a lot of unanswered questions. I personally voted against proceeding with it, but I can give you some more information offline.
I appreciate that. I just hope that when the board has a study session, they are provided with information about exactly what would be studied by whom before people are expected to contribute money to it, because the last thing we need is to essentially contribute to a grease the skid study that ends up disadvantaging many of the users, human and otherwise.
Yeah. And the presentation from the county was pretty much all sunshine and rainbows, so they didn't consider the downsides, and hopefully that'll come up in the study session as well.
Yeah, hopefully some questions will be
people like
asked.
you to ask the right
Oh,
questions.
yeah. Thank you.
All right. Good information. Thank you. Let's see. Any open reporting, water conservation opportunities, information, anything else on that item? And then we do have an item for the WRAC 2020 regular meeting schedule. So as usual, we don't have a meeting in January, and then we also don't meet for the 2 months of the summer. But otherwise, we have the remaining 9 months. Does that all make sense? Okay, so that's just an information item.
And we do always have the option to call a special meeting in the summer if we need it.
Correct. And we can also cancel if we don't need it,
Right.
as it was last month. So make sure we're effective with our time here. Christine.
Please, may I go back just a little bit, the conservation programs on that
Sure.
page? I know we've had
I'm
this.
sorry, which page are you on?
I'm on page 13, countywide conservation programs, the Paso groundwater basin and the Como also. I don't know who can speak to this, but this $6,000 per household for cash for grass, is this continuing, and from where is that money coming? It seems like that's a huge amount to offer any one household to remove grass and do a new landscape. And whose program is that specifically? Is that the city of Paso Robles, or is it the Como Mesa?
Does anybody have insight on the?
The city of Paso has their own program. The county gets the money from building permits. So if you build over the basin, you're paying $16 and some change per square foot or per gallon of water, and they base it on 300 gallons. So you're paying $5,000 roughly per new permit per house, and that money goes for retrofitting toilets, washing machines, and grass and stuff like that, and that's only if you live over the basin.
And it's $1 per square foot up to 6,000, which would be a ginormous area.
Yeah,
So
but that's a huge amount of money, regardless of. I mean, if you've got that much land, you probably can afford possibly to take your own grass. I mean, who has that much grass? And if you do, then
well,
you probably have a lot of that grass too. I would think. It just seems crazy to me that anybody is being offered $6,000 to take out grass. Anyway.
So Christine, I asked planning to be here, but they couldn't make it today. But maybe we could re-ask that question the next time, because this is due for a bigger explanation. So.
Thank you. I would appreciate that.
Okay, so that wraps up our ongoing updates, and now we have a presentation on urban water loss audits and leak detection technologies by the City of San Luis Obispo. I'd like Michael Borman to start us off. Thank you for being here.
Is this thing going to point for me right? Maybe. Is there a laser pointer on this?
Yeah, there should be.
Is it red?
Yeah.
Okay, perfect. All right. I'm Michael Borman, City of San Luis Obispo. Marcus Henderson, who's our distribution supervisor, is going to help me present today. Him, along with Brian Chan, are really the two from the city who have most of the knowledge in this area and have helped us over the last 3 years in progressing our program. Hopefully I can figure out how to go forward on my slides here. So the water loss audits have been available through AWWA for over 10 years now, but they recently became law as of October 2015. And that law requires that once a year in October, all urban water retailers, which is any water agency that supplies 3,000 service connections or over 3,000 acre-feet of water per year, has to submit this water loss audit. So one of the great things that the state actually did, and you'll hear me, which is kind of an odd thing here, but I'll talk pretty well about this regulation because it was pretty well thought out. The state provided resources and training and some early awareness to the urban water purveyors to help us meet these requirements. The very first year, the state came in and they provided funding for free training for all of the entities that were going to be required to submit this water loss audit. So what the state has been doing is essentially using this as a data gathering mission, and they realized early that everyone needs to be submitting similar data in similar ways. And so they gave us all essentially equivalent training that's going to allow us to make that similar analysis and submit data that they're going to be able to look to and make large conclusions on water loss and set regulations on water loss using accurate data. So we went to a series, it looks like 4 or 5 stakeholder work group meetings between 2018 and 2019. And right now they're adopting formal rulemaking, essentially a regulation where they're going to say, by X date, you must do X, Y, and Z. They've also been really good about trying to include stakeholders in that process to make sure that it's a regulation that actually has value to the communities. I'll go through the actual spreadsheet, what we fill out, kind of our process for gathering data, Marcus will talk a little bit about the technology that's out there to help us resolve some of the problems that we discovered through looking at this data. So, AWWA provides a water loss audit spreadsheet that is somewhat straightforward, but really required us to get kind of some specialized training to make sure everybody was using it consistently. What it does is it gathers from us our volume from our water sources. So for the city of San Luis Obispo, largely going to be Nosmano, Whale Rock, Salinas Reservoir. We also account for water exported, which for us is our water that we send to Cal Poly. They have their own rights to, but it's treated at our water treatment plant. And then we take our billing data, which is our authorized consumption, and our water used for things like hydrant flushing and firefighting and things like that. And we essentially look at the difference. So we've got about 4,700 acre-feet of water supplied. After you back out what we sent to Cal Poly, this is what's entering our distribution system. And then we registered on our meters or through approved activities, authorized activities, about 4,400 acre-feet. And our total water loss at a very basic level is the difference between those two. So for the city of San Luis Obispo, in calendar year 2018, it was 311 acre-feet of water, a pretty substantial amount of water, especially probably for some of the agricultural operations here, smaller water agencies. That's a lot of water on the table. So from there, we have to figure out how much of that is water that we're actually seeing lost through leaks, and how much of it is water that we're seeing lost because of metering inaccuracies, poor data handling in our billing department, or other non-real legitimate water loss within the community. So when we break that down, a lot of this right now for a lot of cities is a generic calculation given by the state because we don't have all the infrastructure in place for measuring all of this. So some of these things we have really great numbers on, other things we have generic numbers that are kind of a best guess estimate based on what the state knows. So when we break this down, we see that our apparent losses are things that are not actually water leaking out into the ground, but metering inaccuracies is largely the majority of this number. It's about 112 acre-feet of that 311 total, which leaves for us 199 acre-feet a year of water that we're estimating as being lost to leaks in our pipes. And those can be major catastrophic leaks when we have something like a 10-inch water main break, or they can be small leaks where a meter gasket is leaking, or we have a hydrant that's dripping, or we have a small pinhole leak in a water main. So another way to look at this is we have our volume from our own sources over here, and included in that, that's basically what's input into our distribution system. We're going to take off water exported. You can follow this over. It's not part of the rest of the equation. We have our authorized consumption and our water losses, and this helps us break down proportionally what was apparent loss, real loss, and gives you some examples of what would be a real loss and what would be an apparent loss. So as I mentioned, it'd be something like theft of water for apparent losses, customer metering inaccuracies, which is our metering infrastructure not accurately registering water, which happens for everyone, and then data handling errors where we make mistakes on billing. Real losses is leakage on transmission or distribution mains, overflows of our storage tanks, and service connection leaks, which gives us essentially water that we're not making money off of. We're sending out to the community. It's costing us money to treat it and distribute it, but it's not helping the ratepayer at all. It's not helping us at all. And so we are able, through this calculation, to put a dollar amount on that. And we value the real loss differently than we value the apparent loss. Apparent loss is water that we are using in the community. It's being consumed in people's houses and businesses, but we're not recovering revenue on that. So we value that at what our retail water rate is. And so this $7.53 per unit is our average cost that we would, or rate that we would receive on a unit of water delivered to the public. So for all of our apparent losses, it amounts to about $368,000 lost every year to metering inaccuracies. Our real losses, or what we're losing out in distribution system leakage, is valued at what it costs us to produce another acre-foot of water and send it out into the community. So that's largely our electrical costs, our treatment costs, and pumping from our reservoirs. So there's really not the expectation here that we would have sold that water, but it did cost us money to deliver it. So that's $56,000. But what that really doesn't cover is really extremely high, costly repairs when we do have a large mainline break. For us, we have some larger infrastructure, at least comparatively to some of the smaller places across the Central Coast. And so when we have a 24-inch line break or a 16-inch mainline break, it's going to open up an intersection on one of our main roads in town, and generally going to be hundreds of thousands of dollars to repair. So what Marcus will talk about a little bit is how we try to detect that early, where we can take some corrective measures before a big leak or a little leak becomes a really big leak. And just to put another thing in perspective here, the amount of water that we potentially could save here, and we know we're not going to get all 200 acre feet of real losses under control, but we can get a good chunk out of that. That amounts to the amount of water for the city of San Luis Obispo for 1,200 homes a year. So even if we're able to handle half of that, 500 to 600 homes of water is sitting kind of on the table for us to make corrections on to repair. And when looking at this regulation, all of us agreed that if we're asking the community to conserve water, to cut back, to be responsible, and we have 200 acre feet or 300 acre feet of water sitting on the table, we owe it to the community to do the same thing, to take the same type of preventative measures and same due diligence in repairing these things early. So with that, I'll pass it off to Marcus, and he can talk a little bit about some of the technologies we've leveraged and other ones that are available in the industry.
So we're going to start off with talking about a lot of what Michael's just touched on, the apparent losses and the real losses, because it really is a twofold problem. There's a lot of room to kind of tackle this problem. So we're looking at different technologies to address those two things. So we started out with the higher number. Let's look at those apparent losses and something that we can recoup. Something that we can really do better on was our metering program. So it started off with meter testing, which is really something that we needed to have a better grip on. When we were looking at those inputs, some of the data validity scores that went into that audit software, it laid out sort of our next path forward of how many meters we should be testing regularly and what that testing program should look like. So these are an example of some of the testing devices that we purchased. This, what you're seeing there on the hand truck, that's a large meter tester. It can test meters 3 inch and up. And really, when you're looking at establishing a new meter testing program, you want to start with the biggest meters first, because while we have about 15,000 meters in the city, we only have about 103 that are 3 inch and up. So it doesn't seem like you would want to start there because there's such a small percentage of the total, but when you look at the total consumed through those large meters, it's a much higher percentage versus those other ones. So you want to tackle those big consumers first and just make sure that you're getting accurate numbers on those meters. So that's what we did. So we started out with a contractor that came in and sort of helped us get that program started. He came in with the same type of equipment, kind of trained us on how to use it, and helped us get started. We did about 20 meters the first go around. And just on that first 20 meter set, we found this as an example. That's an 8-inch meter that was feeding into, it was an area that was a pretty large area, but fed multiple small sort of apartments. So to find that meter that didn't start registering until the flow hit about 60 GPM, that was a big deal for us. So when you have a large meter like that is under registering, occasionally it would register accurately depending on the flow, but we knew that at some point during the night there's going to be a single toilet flush that we're not going to be able to capture. So the problem with large meter assemblies, and I'll get to what you're seeing right here, is when you have a larger meter, you don't have as great an accuracy in the low flow range, because you need a large meter for that high flow, but a larger meter can't measure that 0.75, 0.5 GPM flow through it as accurately as a smaller meter can. So that's just something about meter sizing. The smaller the meter, the more accurate it is at low flows. So what we tried to do here is we went back and referenced some AWWA materials, especially on meter sizing, And obviously this is a problem that people have had for many years. So when we went back to the literature, what we found is you can actually manifold a larger line into 2 smaller meters. So what we did was take a single 8-inch and broke it down into 2 6s. So by doing that, we took the starting flow of, even if we had replaced it with a single 8-inch, it would have had a starting flow of about 8 GPM at the low flow range. And by breaking it down and manifolding it, we were able to get that starting flow down to 0.75 GPM and still maintain the high flow capabilities for that facility. So that was a huge help to us. We were able to recover quite a bit of water loss on this site. As you can see, to set it up for the future, we went ahead and installed test ports on each one of these meters, which we can now isolate individually and test without taking the customer out of water. So this was a big win for us. Talking about newer technology for meters, which both of these, by the way, are ultrasonic meters. We've started to standardize our technology so that we do have better accuracy at that low flow range. This is something that we had not had before, a standard single water meter for the entire city. Because cities are built out as developments come in and whatever technology, whatever manufacturer is available at the time. So what we wanted to do was standardize to a single meter, single technology, rather than having Census, Rockwell, Badger, Hersey meters all over. Just have a single meter that we could then use throughout our replacement program. And then, of course, we have purchasing considerations, making sure that we had a purchase contract in place to get the best pricing that we could at the same time. So we needed a standard meter, we needed a contract, and then we looked at the technology. So by going out with the RFP process just to select a vendor and establish that contract, we were then able to evaluate all the different technologies and see what was going to work best for us. So we settled on ultrasonic meters, which are relatively new technology. This model, the Badger E-Series, has been in production since about 2013, but it's been performing pretty well for us. So we were able to kind of look at all the technologies, and this is the one we settled on because of their ultra low flow performance. So a traditional residential water meter, you're looking at a nutating disc type meter that has a set measuring chamber and a disc inside that nutates as the water pushes through it, and it measures those nutations. But if you have a low flow trickling through there, it's not necessarily moving that part, especially over time. When you hit that 20, 25-year life expectancy, those meters start to slow down. So you're getting that low flow leakage that might be going through because you have a lot of older houses in the area that might have some pinhole leaks, and if we're not capturing that, that's what's contributing to that overall water loss. So we went with the ultrasonic meter because it's super accurate at the low flow. At the 3/4 inch meter, we're getting about 1/16 of a GPM starting flow for these meters. And then because it has no moving parts, because it's just a transit time, there's essentially 2 sound transducers that measure the transit time of the water and do that calculation for that set volume to give us a flow range. It doesn't degrade over time. When you start, whatever accuracy you start with, that's what you're going to finish with on that meter because there's no parts to wear out. The downside is they do have a set battery life, which is about 20 years. But when you're getting, and you have that confidence that you're getting accurate numbers over the entire life of the meter, that's a determination that we made it's worth it to go with that. And then again, it's AMI radio compatible if we can get to that point at some point in the future. Another thing that we looked at having the ultrasonic meters is setting up district metered areas. DMAs are something that are sort of new, especially in California, just kind of coming into the scene the last couple of years. So a DMA is it's essentially a smaller scale of the mass balance that you saw before, where we know what's going into the system and we know what's being consumed. And whatever the differential is there, that's what's being lost. So in a DMA, you're doing that on a smaller scale within the distribution system, where you're able to set up something like an ultrasonic flow meter on a main trunk line, a distribution line, a feed to a tank, say, and then you're able to compare that reading against all the residential consumption within that bounded area. It's something that is sort of difficult to do in California, whereas in Europe they've been using DMAs for leak control for a number of years, and they've had the time to sort of set up their distribution system in a way that makes sense for DMAs. Here we have a lot of pass-through systems. We have fire flow requirements that makes it difficult to establish those boundaries and cut zones off from one another so you don't have water leaking into another zone. But there are ways that we can do it. So right now we're working on a pilot program in one of our areas. This is the Farini Heights area. We have a pump station here that feeds up to a tank. We're going to be installing a single meter at this pump station that will be able to tie to our SCADA system. That's going to give us the input number for this pressure zone, the green pressure zone, and then this pressure zone up here at the top of Highland. So that's going to start us off with that DMA and say what's going into this pressure zone, what's being consumed. So this is really, I was telling someone earlier, this is like a couple of birds with one stone, because we need a meter on here for our SCADA system to be able to track what's going through the pump station. That helps us with calculating our pump efficiency regularly, make sure we're not losing any energy draw on that pump. At the same time, we're able to use that number to do this mass balance for the consumption within this residential area. If we use that with our current meter inventory that's there that hasn't been replaced yet, we get an overall age of those current meters. We run that for about 6 months. We pull those numbers and look what the differential is between what's going in and what's being consumed, and then we go through and replace all those meters with our new ultrasonic meters. Then we're going to get an overall sort of accuracy rating of what our current inventory is doing, and which will tell us how fast we need to either accelerate or if we can pull back on our meter replacement citywide. And it's going to tell us what our real leakage is within that zone. So once we know what our apparent loss is, we have confidence in those new meters. Once those get replaced, then whatever is still that differential, we know that that's real leakage. So then we can go start looking for leaks proactively within that zone, maybe some non-surfacing leaks. So that's where this newer technology comes in. So I actually brought our correlator. I'll set it up in a little bit here. This is a leak detection correlator. It's new technology for us. We've just got it this year. It essentially works the same as a transit time flow meter. You've got these two transducers here that connect to these microphones. So you go out in the distribution system if you suspect that there's a leak, say, within 2 blocks. We can attach these microphones magnetically to valve boxes at each intersection that attach to these transmitters and then relay the information back to this receiver, which will be plugged in to the software at a laptop. We can tell the laptop this is 1,500 feet of 12-inch cast iron main. Then these microphones send the sound signal between the two. We measure out and tell them how far apart they are. And then it's going to give us an exact location of where that leak is. It uses a wave velocity to measure the acoustics, and it pinpoints that within 2 feet. So that's going to help us. If we have a non-surfacing leak, we'll be able to find it. If we have a leak that, say we've got a street that's 12 inches thick because it's an ambulance route, or we've got some old concrete streets in town, some of those make it really difficult to find leaks, even if they are surfacing. It's hard to have confidence that it's going to be over where the water is pushing up. Sometimes it follows the trench line, sometimes it comes in a crack. And so this is going to help us on not only locating the leaks, but saving on costly pavement repair costs as well. Something that we're looking at piloting in the future. So the leak correlator is really, if you suspect that you have a leak within a certain area. This next technology is zone scanning, where essentially you can take the same type of technology, these acoustic sensors, but you can attach them to your fire hydrants. So this is what looks like a fire hydrant cap, but it's actually an acoustic sensor with a cellular modem and a battery, and they communicate. You set up your hydrants as nodes within the system, and you would set them up in sort of a grid pattern throughout an area. They communicate with each other. It goes up into the cloud, and you're able to log in and see the entire profile, the acoustic profile of that system. So initially you can find a leak. If it suspects something, you can go out and check it with the correlator. Or if you leave them in the system long enough, they develop that profile and they can locate leaks when they happen. If it notices a change in that acoustic profile, it'll send out a push notification and let you know, hey, this is something that you should investigate. The city of San Jose has been doing a pilot program with these for the last 3 years. They actually were able to locate a leak in Capitol Expressway before it came up, which was a huge savings for them, because if that had taken out Capitol Expressway, that would have been disastrous for the community. Lastly, we're looking at pressure management. So when we're looking at overall leakage in the distribution system, when it comes to real loss, pressure is a direct corollary to water loss. The higher your pressure is, the more leaks you're going to have. As you can imagine, you have a pinhole at lower pressure, it's not pushing out as much water as it will at higher pressure. So you can there is a direct correlation. A 10% reduction in pressure equates to about a 10% reduction in the water loss going through a leak. So pressure management is something we're looking at in the future. It's something that's addressed in the audit software. Are you engaged in a pressure management program? So this is just a picture of a pressure reducing valve. These are our various 15 pressure zones throughout the city. We're looking at opportunities to combine pressure zones. We're looking at using our new SCADA system. This is essentially the pilot controls for a pressure reducing valve, so that now they have pilot controls that have a servo motor that you can attach to your SCADA system. So when your demand drops at night, so if you imagine you have 1,500, 2,000 homes within an area, at night their usage drops off, so pressure will actually come up in the system, you have more leakage. At night when your demand is low, you can use the SCADA system to turn that pilot control down, which will actually lower your pressure at night when demand is lower, which will help on saving water during that time. So those are some of the technologies that we're looking at, starting with our apparent losses, moving down to the real losses, and those are sort of what the targets are for those rulemaking that Michael was talking about. And those are just some of the things that we're doing in the city of San Luis Obispo we thought you guys would like to hear about. Anybody have any questions on anything they'd like to address?
Yeah, this looks very admirable. It's targeted at the distribution system between the source and the user. Is there an analogous system in the collection system for the wastewater treatment plant? Are those leaks amenable to the same kind of technology for detection and repair, or is that a whole different universe?
Wastewater's got the benefit of being able to send cameras down their lines right now. So they can gather a lot of data that traditionally with water we're not able to do because we have a pressurized system. So for our staff annually, pretty much nonstop, they have 2 staff members who are taking internal assessments of their pipes to see abnormalities, areas where we have root intrusion or a joint that's cracked or an area that's settled. So I think they've got that benefit, which hasn't pushed them this direction. And I think it's also just harder if you're not pressurized. You're not going to hear that volume that the correlator is going to pick up on. It's just going to naturally kind of seep out.
Thank you for explaining the difference. So we're talking about pigs, essentially, in the pipe.
Yeah, it looks kind of like a remote control car, the device for wastewater, and they pretty much will just drive it right down the pipe, and it takes a pretty high quality video of the inside of the pipe.
Thank you.
But they are doing some things with their manholes. They've got some things called smart covers where they're sort of able to track the inflow into a particular manhole that might be a summit manhole that would run in a couple different directions. So they have some similar technologies, but again, the problem's not on the same scale necessarily.
It seems that most of your discussion was speaking about residential use. What about all the huge amounts of commercial development?
So that's where the large meter program comes in. A lot of that 103 large meters that I talked about, those are what we're addressing first, is those testing of those large meters to make sure that those are accurate, and then we're proactively replacing the large meters as much as we can.
Okay, thank you.
Is there are you able to, is this like a grant funded program, or is this just general fund?
Right now, this is out of our distribution fund, just regular operating. We do have a CIP set up for meter replacement, and that's been the biggest driver for our replacement costs that we've incurred so far. When it came to the initial round of testing with our contractor, we had some credit with one of the vendors for some old radios from an AMI pilot that didn't go so well. So we were able to use that to kind of cover the first round of contractor testing.
And then just to add a little bit onto that, we kind of examined if it was worth the investment for the correlator. We'll put it out there, though, they cost roughly $20,000 for a correlator. But for us to punch a hole in Monterey in the wrong location is going to cost us probably $20,000 to repair. So for us to have a real sound idea of where a leak actually is, that device for us would pay for itself in a year, no problem. So it's investing money that we were going to be using on kind of an inferior way of doing things prior to having access to this technology and just repurposing it.
Just the time that it will save and the overall payment costs on one bad hole will pay for that correlator.
Do you have a sense? So 2018 was your first audit. I imagine you're chipping away. Do we kind of know where we're landing yet for 2019, or?
Yeah, we started 2017, and we recovered since then. I think it's roughly 150 acre-feet of water, largely through metering and accuracy. So replacement of those large meters. So in about 2 years, that's a pretty incredible amount of water. So the numbers that you were seeing there are more recent than where we started from. And something that's kind of interesting is just when we don't really look at this as a percentage, like 10% of the community's water is lost per year, because as our use in the community goes down, that amount of leakage roughly stays the same. It's still leaking out of pipes. We're still seeing metering inaccuracy. So
artificially inflate the percentage when our usage goes down, so that's why it's not communicated that way necessarily.
Yeah, so the state has some overly complex metrics that they're going to use that are kind of take into account the number of miles of pipeline that we have, how many service connections we have, to try to figure out if we're in a range where we have substantial issues with our infrastructure, or if we're about where we should be.
Yeah, when it comes to the funding about all of this too, we have to remember when we're compensating for those metering inaccuracies, a lot of this can be self-perpetuating in that we're actually capturing the revenue that we would have otherwise lost, which we then can reinvest in the infrastructure.
Have the new ultrasonic meters gotten into the engineering standard?
Yes, as of 2018, we were able to put them into the engineering standards. They are our standard meter now, for 2-inch and below. The 3-inch and up market is a little shaky still on ultrasonic. There's really been only one vendor so far, and starting in October of this year, there's 2 others that are introduced in the 3-4 range. We're still waiting for more than one vendor in the 6 to 8.
Yeah, apart from those large meters and the replacement of the other meters, does that program have a priority as to what meters get replaced in terms of age or leak driven? And the second question is, what percentage of kind of turnover of meters is there every year? Like how many you replace?
So that's there's so many white papers on this that I've been devouring over the last several years. Different ways of doing it. There's a lot of measurement of throughput. There's some are time, some are have to do with the quality of the water in a particular pressure zone. So what we're really doing is looking at that DMA as sort of our pilot test for the overall inventory to see what our inventory is doing, and that's sort of going to inform that next step. We've done some initial testing of some of our meters, but to get a really statistically significant sample citywide, that it's a really difficult thing to do. So we've been sort of relying on other data. We've been working with some other communities. I've gotten some test data from City of Santa Barbara that had about 3,000 meters tested, and we've just been sort of piggybacking on all of those. This DMA is going to help us see what our inventory is doing, and will help us kind of prioritize and strategize from there. So we're trying to do about 1,500 meters a year, which would put us at about 10% per year. That's right now. We're looking at whether or not we need to accelerate that, or if we can pull back using our own data.
And do you know, so the limit right now, or the threshold is the 3,000 meters or 3,000 acre feet. So that applies to a couple other cities in the county. So one, do we know how that's going for other jurisdictions? And two, is there talk of lowering that threshold that would then capture more communities?
I'm not sure how it's going for some of the other communities. I mean, we've had discussions with a few other communities around. I know it's not as big an issue for a couple of communities that believe that they're doing pretty well on meter inaccuracies, and their mass balance shows them. It depends on how you do the math. Ultimately, everybody's had the same training, but the inputs are a little bit different for everybody. As far as capturing smaller groups, that's not really in the discussion right now that I've heard. I've been listening in on some of the stakeholder meetings. Right now, the focus is on the rule setting for real loss moving forward, and that's sort of what all the discussion is happening about what those baselines regulations are going to be and how they're going to apply them. Purveyor-wide, what that actually looks like. I don't know that there's been a lot of push to capture those below 3,000 acre feet.
What's the gold standard for household water pressure?
City, I'd say the gold standard, you want to be somewhere around 70. The actual limits, legally, we can't drop below 35 psi or 20 psi under duress, meaning if there's a fire within the pressure zone, you can't drop between 20 psi. So,
leak management program sufficient to drive a fire sprinkler system?
Yeah, so whenever a new fire sprinkler system is put in, it has to be designed and stamped by a fire engineer, and we haven't not been able to meet that. Pressure reduction is something that you definitely have to build that into the logic of your SCADA system if you're doing something like a pressure management system with your PRVs, so that if there is a high demand, it would override the programming and open back up to full pressure. When it comes to pressure management, we've got 15 different pressure zones. Unfortunately, the topography of the city makes it pretty difficult to level everything out, so we've got a variety throughout the city. But we do always meet that fire flow requirement. If it doesn't, then design has to be put in with a fire pump or something like that for a larger building, and those are pretty rare.
Well, thank you so much. All right, our next item is an update from the WRAC and Agriculture Liaison Advisory Board Collaboration Subcommittee. And that, as a reminder, came out of our water conservation ad hoc task force that we wanted to collaborate with ALAB. So Linda Seifert has a little bit of an update, if you wouldn't mind coming up here and filling in.
Sure. For reasons that are mostly personal from my end, we're not underway yet. I ended up having to cancel one of my preliminary meetings, which I thought was the second meeting that I felt I needed to do in order to sort of prepare me to sort of to oversee the group challenge of figuring out how both ag and urban and the WRAC can kind of work together to figure out what we can do to create some kind of sustainable practices for the ag community in water conservation, or water security is the term is that we're going to be using as we move forward. So just in terms of what our goal will be to prepare a report that can be reviewed by both organizations, WRAC and ALAB, and then hopefully go to the Board of Supervisors for a look. We'll be looking at describing the common goals to enhance water security in the ag zones in SLO County, also to identify existing and potential funding sources that could be accessed and potential legislative measures that could be added to the county legislative platform to enhance funding for water security projects. And then finally, to identify and articulate messages that are common to both organizations. So those are some of the preliminary goals that we've set in my first meeting, and hopefully those will get further enhanced with my second meeting, which will be with James Green from the Farm Bureau before we move further forward. And then as we modify this, we can go and organize a good kind of discussion for a starting group and hopefully be able to move forward and get the task done with relative ease and relative speed. So hopefully that gives you a sense of at least how I think we're moving forward, and I would be happy to answer any questions. Anyone who's interested, we'd love to have good representation from both WRAC and ALAB. So with that, any questions? Thank you.
Perfect. Thank you, Linda. Okay, and then we have we've been doing every month different groups for updates for agencies on water issues relevant to their group or agency. So we have, over the course of the year in our different meetings, made it through every group, but of course not everybody is available for every time their section is called up. So now's our catch-all opportunity. If there's anybody who didn't get a chance to do the update when it was their group section, if you'd like to come up and in just up to a minute to 5 minutes to give that kind of update, we'd love to hear from you. Does anybody want to take this opportunity? 30th. Okay, good. All right, so we will, it's in our bylaws to do it annually, so we'll kind of talk about, see if we want to start up the rotation again in the spring and address things that are going on. All right, and then our final item is discussing future agenda items. And so one, we still are slated to, in the first quarter of 2020, have Mark Batney, is that how you say it? Batney, give another update, soil moisture, evapotranspiration, really important, relevant work. I'd also like to revisit that Water Conservation Committee had 7 recommendations, and so some of them are in progress and some of them haven't started yet, and so I'd like to do that at a February meeting to take some time to go over that. Are there other items that we'd like to add to the agenda? David, then Eric.
Yes, there's a special plan update going on for Los Osos, and it's waiting on the completion of the Los Osos Habitat Conservation Plan. At the meetings of that very large number of people very worried about when all of the lots that have not been sitting there since the 1980s undeveloped get developed, adding well over 4,000 new people to Los Osos. And I would like to hear from the county and perhaps from the water providers how that is going to work in view of the status of the basin at the present time. So, in other words, what will the Estero plan update portions for Los Osos do in terms of availability of water resources?
That seems reasonable.
Yeah,
Okay, great, thank you. Eric, did you have a different one?
That's one of the issues I was going to raise too, that I thought it was timely to look at that. And corollary questions such as, is saltwater intrusion reversible? Because if it isn't, I just don't see putting more straws in the water. And if it is, then what policies can reverse it prior to putting the straws in the water? A couple of other things. One is, I think, the first bullet under future areas of interest, I think what is meant is consider recreational use of water resources to be under the purview of the WRAC. I don't think we want to take on the work of the Parks and Recreation Commission, which is, they've got their own hands full with those sorts of issues. But certainly water-related recreation is, I think, something that, just as with kind of joint efforts with ALAB, there might be a point at which we would be looking jointly with the Parks and Rec Commission at what is the recreational water use picture in the county and so on. But anyway, I just want to be sure that's understood for what it is.
Appreciate that.
And then at the bottom, at one time, I think we had been told that right about now there would be some documents to review on Nacimiento San Antonio Lake Tunnel, but I think I've also heard that that project has hit some snags of one sort or another. Do we know what the status of it is? We're not missing an opportunity to jump on something, are we?
We are not. Last time I was at the Nacimiento Commission a couple weeks ago, and there was not an update. I don't know if you have anything. Yeah, I don't think there has not been enough. There hasn't been any new progress to report on.
Mm-hmm.
So
we'll
keep that on.
We'll stay in the loop if there is.
Correct.
Thank you.
Yeah, but always good to bring it up. Okay. Any other additions or suggestions for content that you'd like to hear about? All right. And then any public comment for items that weren't on the agenda? Christine?
I'm going to take a minute to tell you about a book that I think is a must-read for anyone who is interested in Californian water. It's called The Dreamt Land, Chasing Water and Dust Across California, written by Mark Arax. He was a staff writer for the LA Times. He wrote for the New York Times. He's won a Saroyan Prize award for one of his other books. This is a California history, but written with a very colorful bent. He interviews all kinds of people and starts with the indigenous period of time, goes into the missions, and then into the Northern California water movement and the land destruction during the gold rush, comes to the San Joaquin Valley, moving rivers, the greed of people with hundreds of thousands of acres, those who have money. It's really a fascinating read. I couldn't put it down. I will say that there were a couple of areas with which I have very intimate knowledge, and I got my back up and realized, okay, he has a colorful way of writing, but I also wrote to him and I also met him and talked with him. A couple of comments about my father, my brother's in here. Now, William Malone, I expected that. Okay, fine. But I had to read it with a bit of a grain of salt after understanding a couple of things that I know about. He said when it comes out in paperback, there will be a couple of corrections after I spoke with him. But this is a fascinating book about water and water movement and exploitation and greed, and I can't say enough about it, really. I think it's a must-read. Apparently they have several copies at the library. Some of them are on hold, I understand, but I really want to let you know that I think this is for people who care about California. It starts with Resnick, by the way, ends with Resnick, by the way. But it's a fascinating history, well-researched, huge bibliography. Can't say enough about this book, and no, I'm not giving pennies for it.
One question. Does it go into the history of hydraulic gold mining?
Yes, it does.
And the Sawyer
Yes,
decision?
it does. Yeah, it goes
If
into
there's
all of it.
one,
All right, so we'll have a book club discussion group, an optional once maybe
Just reading
that
this
would be
book.
fun. Tim.
Yeah, just a cleanup item. Ray, I noticed on the attendees that George is still in the Farm Bureau. It needs to be moved up to the Ag Mart.
Yeah, the new sign-up sheet, shows the change.
This is still historic. And we still do have some vacancies to fill, so keep an eye out for those. All right, any other comments, items not on the agenda, anything else? All right, we'll adjourn the meeting, and our next meeting will be February 5th, 2020, 1:30. Note that it's going to be in the council chambers next time in February. All right, meeting adjourned. Thank you. Happy holidays.